Just now to go a little bit into some numbers. So first of all, I googled how much of the sun's energy is bounced off Earth. So after all of it, right, even up after the absorption, etc., how much of that goes back into space? And usually that's around 30%. Okay, so let's say you start with the sun, it's 100%, goes down, it kind of like gets absorbed and then like bounces back, and then it gets absorbed by the atmosphere, right? So, and in the atmosphere, you do have the greenhouse gases that trap some of the heat. And so at the end of the day, around only a third of the sun's rays are bounced back into space. 70% of incoming radiation is absorbed by the atmosphere and the Earth's surface. So 30% is reflected back to space and does not heat the surface. Okay? So then we go into like the emissivity, but I don't really understand why we even have to talk about that, other than Nick Schroeder brought it up in his, essay. So the emissivity of Earth is between zero point 0.6 and 1. Uh, but 1 is highly unlikely, and I'll show you later why. But generally 0 0.6 to 1 is okay. I'm okay with that as an average, right? So, somewhere in between there, let's say 0.75, I would be okay with that. Or 8.5, as they say, actually. It's probably closer to that, right? What is the emissivity of a black body? Well, a black body is, you know, radiated from a perfect emitter, which is called a black body, at the same temperature and wavelength. A black body has an emissivity of 1. But we know that the Earth is not a black body. So I don't understand like this whole Nick Schroeder's thing. Well, he says that the scientists who did some calculations, they assumed that the Earth radiates as a black body. Unfortunately, that's just a claim that he's making. I don't know if that's actually true or not. I really doubt it. And even if you find some kind of, paper, I'm sure that at the end of the day, he is trying to misrepresent the paper. That's what climate deniers do all the time. Okay, next we have. Oh, this is actually one of the texts I think that he quoted. But do note that this text is from 2009, and obviously science has moved on since. I'm not saying that all of that is false, but just we have to be careful because science always adjusts itself, but the articles sometimes are not revised. Okay, so that happens. Again, you can read this article if you want. All the links are in the description. Okay, the next one is, what is it? Is it the same thing? I'm not sure what exactly this is. I think I was looking for works by this Kevin Trenberth scientist. I think that's what I was doing here because there's a lot of articles here. So again, you can go and read that for yourself, okay? But anyway, there's a lot of stuff in there. How much energy is absorbed by Earth in watts? So globally, over the course of the year, the Earth system, land surface, oceans, and atmosphere absorbs an average of 240 watts of solar power per square meter. So 240 per meter squared. Again, I'm not really sure where that fits in. Probably I was trying to see if his equation was legit or not. I'm not sure it was. So anyway. Next one, I know this is from NASA. Oh, yeah. So this is the exchange. Again, these models change over time because we're trying to make them more perfect. And so this talks about the heat budget. You can go and check it out for yourself again. How much heat comes in, how much is absorbed, how much is evaporated, or how much is convected, how much thermal radiation there is, etc. And finally, how much of it escapes to space. Now, these diagrams are not the same because they're talking about different things. So you have to be careful what you're talking about because the numbers change based on what you want to convey. So again, this article, again, link in the description. Next one, just for curiosity, I was looking about emissivity. So what has emissivity of 0? Well, in this case, it would be a perfect thermal mirror. For example, if an object had the potential to emit 100 units of energy, but only emits 90 units in the real world, then that object would have an emissivity value of 0.9. So again, I'm not really sure how this is important, though. I'm not really sure why emissivity is important. This is another article here. Why is it important? The emissivity of the surface of a material is its effectiveness in emitting energy as thermal radiation. Thermal radiation is electromagnetic radiation that may include both visible radiation and infrared radiation, which is not visible to human eyes. By the way, I'm pretty sure that Nick Schroeder, whatever he wrote there, kind of ignored the whole infrared radiation part. Oh, we can't see it, so it doesn't exist. Again, classic. So the albedo effect is important. The albedo effect is basically, how much of the sun's rays are bounced back into space. And you'll find, if you study about this, you find that surfaces that are white reflect a lot more than something that is black. Black actually just absorbs, doesn't reflect anything, which is why it's dangerous. And which is why that, black dust, which they find in Greenland or probably especially in Greenland, it's very dangerous because it absorbs a lot of heat, and that means that it heats up the ice sheets even more, so that accelerates the rate of melt. We don't want that. So you'll notice that there's a scale here. This is from Wikipedia, by the way. So you'll notice that if you look at snow, if it's especially ice, it's very white, and that's good. It reflects a lot. But then you look at, well, ice actually is kind of, it depends on how thick the ice is, okay? Because if it's very thin ice, it's kind of debatable. But if it's very thick ice, snow especially, snow is better. Snow is really white. Ice, an ice cube is not exactly white, is it? I mean, it's not. It's kind of translucent, so it's less than snow. Then I can see why it's lower on this scale. And then you got water. Well, water in general, especially if you got deep water, it's very dark usually. I mean, uh, yeah, it's, you look at the picture of the ocean, it's not, it's pretty dark blue. It's like navy blue, right? So, yeah, not very, albedo is not very high there. You got clouds. Clouds are good. Clouds are fairly white in general, so they reflect a lot of that sun rays back into space. The desert is like okay, but it's not, again, not great. Forest though is not very good. Forests are green, so, but it's kind of dark green. It's not very good. Once again, meadows is a bit higher than forest. Well, because it's a bit lighter green. And then crops, again, crops is a bit, again, a bit higher because it's maybe yellow, like if it's wheat or something like that. So it's still a great higher. But anyway, the albedo effect, yeah, the albedo effect is very important for Earth, so I highly recommend you go and look it up. I looked up, so these scientists now, so Kevin Trenberth, if you look at, this is from Google Scholar, if you look at the number of publications, etc., citations, all citations, 118,000. Since 2017 alone, 43,000. And you can see there's a bar here, goes up all the way to 2022. It goes down to 2022, but that's because obviously this year has not finished yet. So, but in general, this scientist gets about 8,000 per year, which is a lot. And you can read all his articles that were published. You can see the year that they were published. You can, you can sort them out by year if you want. You can sort them by citations, unfortunately, but you can see the number of citations that they get. Uh, Another one is so John Cook. I interviewed John Cook before. He's more towards like kind of the psychology part of climate change. Like he analyzes human behavior and how people react to it, but not limited to that. Anyway, his number of citations is 10,000, but just since 2017 alone, over 8,000. So definitely in recent times, he's on a sharp rise, which is good to see. He's a nice guy. He was very open to get an interview, uh, give me an interview. So thumbs up for that. Again, you can see all the articles published by year. Oh, you can't sort here, but you can sort by citations for some reason. It's kind of inverted. I don't know why. I don't know how Google Scholar works. So anyway, you can check it out. But again, 10,000 is a lot of citations. And then you go to Nick Schroeder. Let's see how many citations he has. 166. Ouch. Only 32 since 2017. But wait a second. Wait a second. Nicholas Schroeder, professor of accounting, University of Toledo, that's not even the same Nick Schroeder. And that's because it's not. This is a different guy, okay? So yeah, I just took that kind of as a joke. This is not the same Nick Schroeder, okay? Uh, at least this Nick Schroeder, who was published back in the 80s, has a few citations here and there. The Nick Schroeder that I was talking about, that guy is not listed anywhere. Okay, this is just forget it. This is just a translation test I was doing, so I forget that one. And so finally, I just want to finish off with this point. So the Nick Schroeder I was talking about, the one who posted that crap comment on my climate change course, he claims to have a BSME. So what is a BSME? Well, it's a Bachelor of Science degree, BS, in mechanical engineering. Apparently, I don't know if that's true, but apparently this is the same degree that Bill Nye has. But okay, yeah, forget it. So anyway, Bill Nye also has BS in mechanical engineering. Uh, but the thing is, like, this is very kind of odd here. So just follow me, bear with me for a second. A lot of the climate deniers, they attack people like Bill Nye. Like, oh, look at Bill Nye. He's just a mechanical engineer. He doesn't know anything about climate change, right? And I'm saying, like, that's a kind of almost like a straw man, because Bill Nye is not the go-to authority on climate change. He's not. He's knowledgeable on the topic, sure, but he's not the kind of go-to guy when we need climate change advice. Okay, so why is he on TV all the time? Why is he giving interviews? I'm not sure. Well, that's because probably a lot of people know him, and maybe he's available. He is knowledgeable in certain topics, very knowledgeable. So maybe there's a combination of, it's not just like one thing. It's usually a combination of things. Okay, we have to book. Who can we book? Oh, Bill Nye is available this week. So let's go with Bill Nye. But look, he is not the kind of go-to authority on climate change. There's a lot of much better people who are much more well versed in the topic that I can recommend. John Cook is one of them, definitely, as far as psychology is concerned. Um, so yeah, that's a very strange kind of attack point. Bill Nye, Bill Nye. I have the same degree as him, so look at me. I came to these different conclusions. Okay, fine, whatever. So mechanical engineer, though, you have to be very, very careful, because a mechanical engineer is not the same as a climatologist. Okay, just very quickly here. Later, we're going to talk about climatology. But mechanical engineering, just to finish off with this point, if you go to by the Wikipedia definition, it says mechanical engineering is an engineering branch, which is a very old branch, by the way. but that doesn't really mean anything in itself. It combines engineering physics and mathematics principles with materials sciences to design, analyze, manufacture, and maintain mechanical systems. It is one of the oldest and broadest of the engineering branches, which I said earlier. So, yeah, basically, it's to design some kind of machines. Like they have, I don't know, pictures of somebody assembling a car or some engine, something like that. This is very, very different from somebody who studies, weather patterns or climate patterns. Very different indeed. You could almost say that it's completely different fields. And if you look at one definition, anyway, of what a climatologist is, first of all, you need a degree in climatology, meteorology, or atmospheric science. Now, this is kind of interesting to me because I know there's this one guy I know, very rich guy. I'm not gonna say who he is, obviously, and where he lives, but very rich guy. But just on stocks, like mostly from stock trading. Okay, so he's not like some kind of company owner or anything like that. He's just very good on the stock market, and kudos to him for doing that. But that doesn't mean that he actually knows much about anything. Okay, so he said, well, I was exchanging emails with him a while ago, and one of the things that he wrote to me was he thinks that a degree in climatology is a joke. Like it doesn't. He actually said that it doesn't exist according to him. Okay, this is nonsense because today you can study climatology, but usually it kind of falls into more into physics. But you would study things like about the climate, and the climate is usually the averaged weather over a long period of time. That's true. Uh, but you also understand the different interactions between the different layers of the atmosphere, and how the greenhouse gases interact, uh, how much heat they're trapping, etc. You would definitely study about all of that. Now, I can guarantee you that a mechanical engineer, just going from at least the Wikipedia definition, this is a person who does not study these things. So yes, you are technically speaking a bachelor of science. I'm actually a bachelor of science as well. I studied multimedia computing, um, which was such crap, by the way. But I am technically a bachelor of science. It doesn't mean, though, that I'm actually a scientist. Okay? I'm not. So it's the same with mechanical engineers. They are mechanical engineers, but when it comes to like, are they actually scientists though? Well, some of them might be. It depends what they pursue as their career. But I'm sorry, but if you're just building some car or some engine, you're not a scientist. You're a engineer. You're a builder, constructor, whatever. But yeah. Anyway, look, that's it for my video. That's all I wanted to say, really. There's a lot of here, there's a lot of stuff, and all the links will be in the description. So, like, literally, even my Google searches, which may be irrelevant to a certain point, I'll even include those. So you can check it out for yourself. And definitely, that Nick Schroeder guy is full of crap. And one last thing I will say here is, and I did give that warning, in fact, in my course. If you do, like me, these type of climate change courses, I actually encourage people to do that because we need more voices out there. The more voices, the better. Especially, well, you do need to know about the topic, obviously. You can't just make shit up. But if you're knowledgeable about the topic and you have enough confidence to present the material in an interesting, compelling way, by all means, go for it. Definitely, you should do that. And one thing I did warn about in my course is you are gonna get comments from people like Nick Schroeder and other climate deniers, who come into your comment section or whatever, and they start to spout some nonsense, and it might sound intimidating. It might sound like a personal attack almost. But don't let these people walk over you. Don't let them intimidate you because, yeah, as I pointed out, a lot of the time they are part of, well, first of all, they are part of the pro fossil fuel lobby. Okay. So they are pushing more fossil fuels. That's what they want, basically. So whether they're paid by the lobby, we might never know. We don't know. They might be just very kind of highly motivated individuals, but they are pushing this pro fossil fuel point of view, which is very dangerous these days. Now, the other thing, of course, is that if they do write some publications or whatever, it might very well be for some place like Principia Scientific, which, as I pointed out, is not scientific at all. So yeah, you have to, you have to find who they are. Like, who are they? Where are they writing? If they're writing at all, uh, go go follow the source. And then usually what you'll find out is that, yeah, it is somebody who's working, either really working for the fossil fuel industry, or somebody who's like pushing the fossil fuel industry talking points. So either way, it's not good news. And so don't let these people intimidate you. Just don't. You can try to reason with them, but usually they don't want to listen to anything. They're convinced about their point of view, and they're not going to budge on that. And in fact, their whole purpose of being in your comment section is to budge you, not to change their point of view, is to change your point of view to theirs. So yeah, they're not interested in the truth. They're just interested in parroting some fossil fuel talking points. And so I actually think that is really pointless to try to engage with them. And at that point, my recommendation is probably just to block them, because again, they're just going to pollute your space, and you don't want that. You don't want that. So, but again, it's up to you how you deal with these people. Absolutely up to you. But just my recommendation, because I've dealt with that for many years, it doesn't like go anywhere. You see, you're not going to convince him. They're not going to convince you, obviously. So, but they might sway some people, unfortunately, to their point of view. Like, people are going to say, well, maybe greenhouse gas theory doesn't is not true, actually, right? And yeah, you don't want to facilitate the spread of misinformation. Let's just put it like that. So I'll leave it on that note. This is already way longer than I expected. But anyway, yeah, so don't let them intimidate you. And check out my course. Again, the link will be in the description. It's a very good course. It's meant for beginners to intermediate students, but also obviously it's open to experts as well. It's a really great course. I'm really proud of it. Like, I really put a lot of effort into it, and I think it came out well. So, share it with your friends, share it with your family if you find it interesting. I don't make any money from it whatsoever. It's on YouTube. Look, it's free. There's no ads, there's nothing. I'm not making any profit whatsoever. So, it's really just kind of my service to mankind. It's going to be available forever, even after I die, which I think is fucking awesome. All right, that's it. That's it for today. I'm signing off. So take care, stay safe, have a nice day or evening, night, wherever you are, and I'll see you around. JC signing off.